This video explains how to use the property functions of the DIPPR MATLAB Function Suite. You should have watched the videos on exporting dipprread data to Excel and using the dipprread function before watching this video. The DIPPR MATLAB Function Suite provides functions that calculate the compressibility factor, molar volume, residual enthalpy, and residual entropy at a given temperature and pressure. Values for both the liquid and vapor phases may be calculated by calling different functions. If the system temperature is above the critical temperature of the compound, both the liquid and vapor functions return the same value, which is that of the supercritical fluid. Functions are also provided that calculate the change in enthalpy and entropy between two states at T1P1 and T2P2. These functions will use the DIPPR properties to determine the phase of each state. If the phase is a solid at one or both the state points, an error is returned. An error is also returned if either of the state points is at saturation, as the functions do not allow specification of the fraction vaporized. Each value may be calculated using either the Soave-Redlich-Kwong or the Peng-Robinson Equation of State. The residual or departure properties at temperature T and pressure P are defined as the value of the property at T and P for the real gas minus the value of the property at T and P in the ideal gas state. The functions in this table calculate a property at a single state point defined by T and P using the SRK equation of state. Each is called with three arguments, T, P, and C. T is the temperature in Kelvin, P is the pressure in Pascal, and C is the variable with the property data that is obtained from the dipprread function as described in a separate video. The units on the return values are found in the documentation. Volume is given in meters cubed per kilomole, enthalpies in joules per kilomole, and entropies in joules per kilomole Kelvin. Similar functions are available for the Peng-Robinson Equation of State. The functions to calculate delta H and delta S are shown here. The inputs are the temperature and pressure of state 1, the temperature and pressure of state 2, and C, the variable from the dipprread function. Consider hexane as an example. C6 is the name of the variable for the data returned from the dipprread function for hexane. The following command is used to calculate the residual enthalpy of the vapor at 300 Kelvin and 4 bar using the Soave-Redlich-Kwong equation of state. This function reads the DIPPR values for the critical properties and the eccentric factor from the C6 variable, determines the SRK parameters, and uses these to calculate the residual enthalpy of the vapor in units of joules per kilomole. The command to use the Peng-Robinson equation of state is shown here. As another example, consider calculating delta H for the isothermal compression of propane from 1 bar to 10 bar at 300 Kelvin. Using the Peng-Robinson equation of state, this is done with the following command. The change in entropy can also be done. Please see the documentation for the DIPPR MATLAB Function Suite for more information on using these tools.